Hello everyone. So let us continue with the P2 subroutines. As we discussed last time that I furnished all the basics. Taught all the basics and today we will be covering the past papers as well. So let's first revise a little and then we go further. Okay? So as I said that subroutine is basically the decomposition of a bigger program into number of smaller parts so that those smaller parts could be distributed among the programmers as per their expertise. Those smaller parts later with the passage of time will make a library that can still be reused in later projects. The distribution of smaller parts will give you the benefit of having the whole development done in lesser time. And with the passage of time, when the library of these subparts will be created, we will have another reason to reduce the time of the development. Hello Taha, it's been long. कहाँ हो भाई? कोई राब्ता नहीं, कुछ नहीं. I hope that you are studying computers. So, what I was actually teaching were the benefits. Now, when it comes to disadvantages, disadvantages are not in terms of disadvantages, rather they are in terms of challenges. You see, when the bigger programs are made, there will be so many more little programs, sub-programs, modules in this approach. Then putting them all together to make them communicate effectively, to make a program which is basically a better program, to use only those subroutines which are required when the time comes. Overall smart association of these subroutines will be actually toll taking. Bigger the number of subroutines, there will be more challenges. So this could be the disadvantage. Disadvantage is more effort actually. Now, so we had a bigger problem, we divided it into sub-problems, and then we evaluated every sub-problem. If we can further divide it, we further divide it. We divide it to the level when it is not possible to further break it down. That's it. Now, every subroutine that we have can be distributed among the teams or the persons. Those persons will do their part, they will test their part, and then they submit the whole thing back to the project manager. Then project manager and the team working with him will be putting everything together in the form of a single program. Then this program gets ready. So this decomposition is also called modularization, top-down design. And these decomposed parts are called subtasks, modules, subroutines, procedures, functions, whatever you call them. Now, so this top-down design, the definition of it is breaking up of a bigger development task into subtasks and reviewing every subtask for any possibility of further breakout. Keep doing this until subtasks can be further broken down. Now, these are the parts that we have to study. These parts over here, scope, types, parameters, and structural chart are practical, means that you learn them and you can practice them. Whereas these parts which are debugging are limited to the theory in our syllabus. So, scope of variables, all those variables which are defined outside these subroutines are called global and they are shared variables, then they are available to any of the subroutine whenever it is required, and whenever a subroutine is updating this particular variable which was shared by having it declared outside any subroutine, the change will be available right away to all of the other subroutines. Such type of variable which is declared outside the subroutine is global and shared. Whereas a local variable is basically the variable which is declared inside the subroutine. Walaikum assalam, Mas, which is declared inside the subroutine. So they are at the discretion of the subroutine, the programmer who is programming that subroutine, whether they like it to be shared or not. If they like it to be shared, it means local variables I'm talking about. These variables can only be shared if you wish for it. As a subroutine developer, it means that when one subroutine calls another subroutine, the caller can send the variable to the other subroutine. So this is private sharing, if and only when it is required. So those variables which are made inside the subroutine are not freely available to other subroutines, as were in the case of shared or global variables. All right, so those variables which are declared inside the subroutine can only be shared with the called subroutines whenever the programmer requires them to be. So what is the word scope? Scope is the life of the variable, how long it is available. So when you call a subroutine, and subroutine has got few local variables defined inside it, so as long as that subroutine is working, being executed, those local variables are alive and working and thriving. As soon as that end subroutine, end function, end procedure is executed, all are gone out of the memory. So, but if the variable is basically outside any of the subroutine, in that case, that subroutine will be all of the subroutines will be able to share that. So the scope of that global variable will be available to all of those. So the life of the global variable is starting when the program is started and will be ending when the program is ending. Whereas the life of the local scoped subroutine is only available when basically that particular subroutine is being executed. All right. All right, Malik Rohel, that video is already made and uploaded. So search using YouTube like full header, ZAK on web, flip flop, ZAK on, and you will find it. Or if you do remember that chapter, that is 3.3. So look for the playlist, and the playlist, in the playlist which is representing chapter 3.3, you will find all these. Okay, they are already there. They are already there. Sir, will you do P4 crash course in Visual Basic? I can say that, but I have few plans. I will be telling in April. Now, afterwards we have got type. Type is basically the types of the subroutine. There are two types which are in our syllabus: the procedure and the function. Procedures are those subroutines which may receive shared variables which are said to be parameters, which may or may not receive the shared variables, but they do not return any value. So if they are returning a value, it is function, and if they are not returning any value, that is said to be the procedure. Function always returns a single value. So the procedure, which is a subroutine, if it does not return any value, then it is said to be a procedure, and if it does, then it is said to be a function. So there are two types of functions: simple function and recursive function. Recursive functions are no more with AS; they are in A2. We will discuss those next year. and simple functions which are in AS. We will discuss them now. Now, those local variables which are being transferred from one subroutine to another subroutine when one subroutine calls another subroutine, they are said to be the parameter. It's like having one monitor in the class, although that monitor is also the student of that class, but it would have a greater distinction by having him a status which is of the monitor. So these parameters are also the local variables like others, but they are being used for sending and receiving the data when one subroutine calls another subroutine. So these are the privileged local variables which are being shared with another one. Okay. Now, uh, there are two types: actual parameter, which are local variables which are being used to send the data, and formal parameter, which these are the local variables which are being used to receive the data. Okay, so actual subroutines, actual parameters are those which are being sent. Formal parameters are those which are being used to receive the data. Now, sometimes actual parameters are called arguments, and in that relation, those are formal are called parameters. So whenever you hear the word parameter in past papers or in your syllabus, it means those variables which are being used to catch the value which is being shared by the caller. Okay. So passing of the parameters. So when the parameters are passed from one subroutine, from caller to another subroutine to the called one, they can be passed by value or by reference. So in by value, what basically happens? Let's say subroutine A has got two variables, X and Y. Okay. Subroutine A has got two variables, X and Y. So as soon as in subroutine A, those two local variables are declared, there are two memory locations which are basically made in the memory. Okay. Now, when subroutine A calls subroutine B, when subroutine A calls subroutine B, subroutine A transfers X and Y, and subroutine B, when receives it, will create two more memory spaces. Okay, so subroutine B will create two more memory spaces, and those X and Y variables will be copied. Okay, those X and Y variables will be copied to those new locations. So subroutine B, whenever it is making a change to N and M, which they have used to receive the values from X and Y, okay, in that case, basically, this is called by-val. Okay, so now this is said to be what? This is said to be by value. So when subroutine A is calling subroutine B, it is transferring the values from X and Y, but those values, when they are received, they are being received in another two variables, and those values which are being transferred are copied to those two new variables. This is said to be passing parameters by value, means making copies and use them. Whereas in by reference, what basically happens, instead of receiving those variables in another subroutine in another two variables, what will happen that those two variables will be pointing to the same location as X and Y. So when subroutine A will be creating two variables, declaring two variables x and y, they will be in the computer's memory. And when subroutine A calls subroutine B, when subroutine A calls subroutine B, subroutine A transfer the values, but those values will not be received and in another two different memory locations. Rather, subroutine B will be calling them though n and m, but those n and m will be pointing to the same memory locations as of x and y. So in that case, whatever the value that will be changed in n and m at subroutine B side while it is being executed, that change will be made to x and y as well, because these n and m are two different names for the same memory locations as x and y. So let's say if subroutine B makes n 10, it means that y will become 10 automatically. So this is passing parameters by reference. Okay, reference to what? Reference to the memory location. So by reference is used to save memory location. No, Arham Khan. It is not being used to save memory location. There is a different purpose. The purpose is mostly, let's say if there is a subroutine procedure to which we will send several values, only one or two of those values will be the values which are being passed from one subroutine to another. The rest of the values will be used to catch the worked output of the procedure which is being called. So subroutine A calls subroutine B, subroutine does something and updates the variables, and those variables will automatically be updated in subroutine A. There is another thing which used to be taught earlier, that when you like to have more than one values returned from a subroutine, it is a good idea. It is a good idea that to pass them with by reference. So the subroutine which is working around it will be updating its own variable, and those variables will automatically be updated in subroutine A. So if you like to have more than one values. Sir, in by value subroutine, if we use same variable name x and y, will it be overwriting the original variable? No. It's like two different persons with the same name are living in their own respective homes. So that is purely fine. Two different subroutines would have two different variables by the same name. Still, they are two different variables. Okay, so they would be in their own subroutine, in their own memory area, and they would have nothing in common. So this is a common practice, that the subroutine which is calling with the name of the variable is the same as the subroutine which is receiving those variables with the same name, but the caller's variables and the receiver's variables are two different variables. So do not think that way, that if we name them both, they will be same. No, ऐसा कुछ नहीं है. So अगर ये possibility होती तो I would have made by ref. Okay, so all right. So now these are passing. Now passing of the parameters from one subroutine to another subroutine can be depicted using a chart which is called structured chart. Okay, which is called a structured chart. Now, so subroutine A is calling function sum. So z is equal to sum of x and y. So these x and y are basically the argument or the subroutine which are being sent from one subroutine to another. So we will be using these two shapes. These are called data couples, a circle and an arrow in front of it. These two represent basically the parameters. So x and y are being sent to function sum. Remember, this line does not have any arrow or anything. Only the arrow in the data couple will be pointing that what is going to be transferred from which subroutine to what. And then whatever the value which is being returned from the function sum will be caught in Z. So a value is coming back. As I said, that subroutine function returns a value and subroutine procedure does not return a value. That is how it is defined. So this subroutine is calling this subroutine and transferring two variables. These two variables are being received in n and m. So what are being transferred are either the actual parameters or called argument, and those which are being used to catch those variables are called just the parameters or formal parameter. And the one that is being returned is basically the returning value, and it is a parameter as well. So x and y are arguments. If they are arguments, then n and m are parameters. If x and y are actual parameters, then n and m are formal parameters. And whenever you hear the word parameter, mostly your syllabus is actually pointing to the parameter, the local variables which are being used to catch the values. Now, in here, subroutine A is calling subroutine B, so we can also show it like this. Since this is a subroutine procedure, so it is not returning a value. So this is said to be the structured chart. The structured chart defines at which subroutine sending what to another subroutine. All right. So let's start with the past papers and make it firm that we have a good idea of. जी जी साहब नवाब, ये एक ही कॉमन टॉपिक है, ये आगे पीछे दोनों में एक ही जैसा, P2 में डिफरेंसेस नहीं है. All right. So white box testing, what is white box testing? White box testing is checking code line by line. Checking as in tracing. Code line by line as in through logical pathways. All right. Checking code line by line against pre-decided values and expected outputs. So when there is a developer who is actually making that particular part of the whole program, once they are done with it, they want to check it. So they will already be provided with the input values and expected outputs. So they are checking it by line by line, line by line. All right, checking all the logic that flows through. So tracing code through logical pathways. So these two words, tracing and logical pathways, are basically from the past paper, so it is a good idea. So when the one who does the subroutine himself, they're checking it line by line, sort of tracing. After completing the development, it is said to be white box testing. Explain what is meant by white box testing. We discussed about it. Complete the table heading. So basically, complete test number 1, test number 2. So this is irrelevant at the moment, but I think that this is hours, this is minutes, this is seconds, and these are total seconds. Race, total seconds. Okay. Now, a program displays a menu with choices 1 to 4. The code to display the menu is written as a procedure display menu. So this display menu is called. Okay, pseudocode which uses this procedure is this. So this display menu displays the menu with all 4 options. And then there is a loop working, repeat and until. So this loop is basically range validation check. What does it mean? Range validation check means it is making sure that whatever the input that you make, that should be between 1 and 4. If it is 1 and 4, then it gets out. If it is less than 1 or greater than 4 or something else, it will keep you inside the loop, telling you to enter choice between 1 and 4. So describe what this pseudocode will do. It will run a loop, and that loop will keep you inside the loop until you do not enter from 1 to 4 choice. State why this loop is required. This loop is required for the validation check, so that user only make those choices which are available through the display menu. The following pseudocode is revised, designed. Okay, so there is a constant I. Constant is basically the empty variable. Variable changes value. Constant does not change value throughout the execution of program. So then they call display menu. As usual, display menu will be shown number of attempts. So it looks like that. Now the repeat loop will provide you with the option to re-enter if you are making a wrong choice, but only up to 3 choices. So number of attempts. So this looks like I'm not sure about it. This looks like that number of attempts will be increasing every time you are entering a number, and if you go beyond 3, it will do something. So let's see. So number of attempts is a variable which is 0, and there is a constant added. Now the prompt is shown, input is taken. Now number of attempts is equal to number of attempts plus 1. So it means that as soon as you make an input, number of attempts is increased. And then it says that either the choice is between 1 and 4 or number of attempts is equal to I. Same thing. So if you are making the choice between 1 and 4, you get out of the loop. Which loop? The validation check. Which validation check? Range. What is range validation check? It actually makes you enter the data between start and stop, lower bound, upper bound. Okay, so this is from 1 to 4. Or in case if your number of attempts increase and reaches to I, it means that you have already made 3 mistakes. In that case, get out. So it will not be lifetime. So it will take 3 turns just to make sure that you enter from 1 to 4, and if you don't, it will get you out anyway. Give the maximum number of inputs the user could be prompted to make 3. State why this algorithm is improvement of the given part in A. Because in given part A, user will never be able to exit the loop. So in this case, if they make 3 mistakes after that, they will get out of the loop. Program will not stuck to just one input then. The pseudocode is in its initial stage of development. Okay. The table below shows the action currently taken by the pseudocode following each menu choice. Okay, so menu choice is 1, 2, 3, 4. Description is this, and then when you make choice 1, it calls the procedure read file. When the choice is 2, it outputs the message this. When the choice is 3, it outputs the message this, and then if the choice is 4, it ends the program. Wonderful. Okay. Now, complete the pseudocode for the program. Okay, so we have done it. Complete the pseudocode for the design part B shown again below to respond to each menu choice. So it means that after this, once you get out, you would have either a choice or number of attempts which are equal to I. So you'll be like, if choice is equal to 1, then call what? Read file. Okay, then call read file. So these 2 parentheses will make it sure that yes, you know that this is a procedure. Okay. Now, if choice is equal to 2, then output add customer code. If choice is equal to 3, then output search customer code. And then if it is 4, do nothing. Program will end automatically. Okay. So if you like, you can put if choice is equal to 4, then end. This end is a legitimate command that points out uh, to the point where the program ends. Okay. So I want the maximum number of inputs be 4. Number of attempts start from 0 and ends on 3. Bete, if you do know about this repeat until thing, as soon as this is true, system gets out. In while के अंदर आप देखिए ना, initially is 0 है. As soon as you enter, it becomes 1. You re-enter, it becomes 2. You re-enter third time, it becomes 3. As soon as it is equal to 3, it gets out. So the repeat until makes sure that whenever the condition is true, it gets out of the loop. Okay? It gets out of the loop. Sir, can we write and if choice is equal to 4? No. Why do we write this? This is not correct. Alright? Get the ideas? Now, this can also be written using case. In that case, we will write case of choice. 1, do this. 2, do this. 3, do this. End case. Alright, this can also be done this way. The algorithm in part C is to be amended. The program will repeatedly display the menu and respond to the user's choice. Terminate when the user enters 4. Write program code for this final design, which will made up of the main program, the procedure read file, the procedure display menu. They want you to have a program in Visual Basic and all. Now, since in 9618 it is only pseudocode, let's amend the pseudocode. So it says repeatedly display the menu. Okay, repeatedly display the menu and respond to the user's choice. Terminate when the user enters 4. Okay, so over here we will write repeat. So it will call display menu. So display menu will be something like along these lines: procedure display menu output one to do this, output press 2 to do this, output press 3 to do this, and output let's say 4 to end the program. End procedure. Alright, so this procedure is done. I think they are not concerned about this part, they are only concerned about the procedure and end procedure part. So this procedure is called number of attempts is initialized to 0, repeat starts. Afterwards, after this until, what we will do, we will put this part over here. Okay. After this part, we will put repeat until choice is equal to 4. As soon as choice is chosen as 4, system will leave, it will get out. Okay, it will get out. And in case if it is with this number of attempts or number of attempts is equal to I, in any of these case system will get out. If you would have choose, let's say 1, so this procedure will be called system will get back from the until. It will check that have you pressed 1, no you, sorry, have you pressed 4, no you haven't. Is the number of attempts is equal to I, no, so you go back. All right, to repeat, it will show the menu again and it will go on, it will keep going on, as they have said that repeatedly display the menu and respond to the user choice terminates when the user enters 4. So when this will be 4, it will get out, and once it is get out, put end there, program will be ended. That is how it will be done. So you get 8 marks for it. See, sir, why not else if instead of just if? Why do you want to make the whole program more complex when it can be written this way simply? You see, Saad, basically what happens that when there is just one single statement against every choice, when there is one single statement against every choice, you don't have to put that statement in next line or use else, if and all. Just keep it simple. All right. Yes, you can do that either way with else if, with the else, and then inside else there is another if. You can always do that, but this looks more readable and sensible. All right, so would you please hold on for a sec? Ji Janab. Question number 3. When the guarantee on a computer runs out, the owner can take out insurance to cover breakdown and repairs. Okay. Now, this is basically a question which does not have any roots in terms of any defined data and all. So they are basically seeking your idea about the structure chart so that you have a fair idea of what is happening, what is a structure chart is all about. Okay, so first you need to see that what are these subroutines, and then what sort of values can go from these subroutines to or shared. All right, so let's see what is the name of this subroutine, what is the name of this subroutine, what is the name of this subroutine and this subroutine, and then afterwards we will go further. So let's first read it out. When the guarantee on a computer runs out, the owner can take out insurance to cover the breakdown and repairs. The price of the insurance is calculated from the model of the computer, which is G. Model of the computer G. Age of the computer is H. The current insurance rate is policy number. It is not given. All right, current insurance rate is not given. It will be probably calculate price. Insurance rate will be calculated. So now, following an inquiry to the insurance company, the customer receives quotation letter with the price of the insurance. All right. So this is a quotation letter with the price of the insurance. Okay. Now, using letter A to D, बिल्कुल आ सकती है. ट्रेसिंग तो आएगी बेटे. Send quotation letter, calculate price, produce insurance quotation, input computer details. So first of all, it is input computer details D. Then produce insurance quotation. Which is C. Produce insurance quotation, which is C. Calculate price, which is B. And then send quotation letter, which is A. So the input will be made, values will be calculated, and then the letter will be sent. All right. Now we have to decide for the variables. I'm not going to cover all of these variables since this question has no roots. This is just a sort of question which describes a situation. For that situation describes few variables, and you would have to determine that which variable will be used when. So even if we pay attention to this question and we go whole length of it, this question would not be able to prepare you for the upcoming questions. So these are extempore questions. These are out of blue questions. These questions are some sort of those questions which are just there for the practice. So I'll be doing it a little and you complete it yourself. Okay, so when we take input, what sort of input we will be requiring? Model number and age, G and H for sure. G and H for sure. Okay, the current insurance rate will be calculated. Okay, na? Premium rate will be calculated. So what will be the third value? So let's see. Customer name, customer email. Okay, customer name and customer email, and then model and age. Okay, now we are taking just three. Customer name and customer email, we also be requiring those. Customer name, E and F. Okay, Now G and H are going to be, the premium rate is calculated, that is said to be the policy charge. That policy charge is basically I, that will be calculated, and then along with other values that I will go towards A and the letter will be sent. So you complete it yourself. Let's move on. A game is displayed between, the game is played between two players. They take turns at rolling six-sided die, 1 to 6, and record their throw. A player scores 1 point if their throw is higher than their opponent. They each roll the die 20 times. If the player's throw is same as the opponent, the total point is unchanged. Bete, you decide it yourself. Okay? I'm not going to spend any more time over such questions. Okay? You decide it yourself. You would have a marking scheme. Go deep into it, you find it. Okay, Bete? Though I'm talking to you. Now, all right, a player scores 1 point if their throw is higher than the opponent if they each roll the die 20 times. If the player throw is same as their opponent, the total point is unchanged. The winner in this game will be the player with the larger number of points after 20 throws. The pseudocode will use variable number of throws, loop control variable. Okay. Now, complete the pseudocode for the given algorithm. For over here, we would have next. We see. Okay. So for something is equal to number of throws, do we have any variable? No. So let's say for count is equal to 1 to 20. Input player number throw. Player 1 throw, comma, player 2 throw. If player 1 throw is greater than player 2 throw, then player 1 total, I'm taking it from here, player 1 total is equal to player 1 total plus 1. If player 2 throw is greater than, there will always be a contradictory statement that you would have to look forward to. So if it is player 1 throw, then there is player 2 throw input. If it is checking if player 1 throw is greater than player 2 throw, afterward it is checking if player 2 throw is greater than player 1 throw. So whatever the statement over here is for player 2 throw, over here it will be for player 1 throw. Alright, so this is player 2 total, this is player 1 total. Alright, so that is how it will go on and on and on and on and on. And then here is next. Once all 20 turns are completed, then we will see if player 1 total is greater than player 2 total, then we will output player 1 is the winner. Else, if it is not that case, then it will be outputting player 2 is winner. Now you see what is the problem. There are three cases. Player 1 total is greater than player 2 total. Second one is player 2 total is greater than player 1 total. Third one is player 1 total is equal to player 2 total. So it can check for this part, but these two will be in else part. So it has to be much more clear. Identify the game result which will produce incorrect output. When player 1 and 2 totals are the same, still it will say that player 2 is the winner. Although it says if the player's throw is the same as their opponent, the total point is unchanged. Okay. And then it says that the winner is the player with the larger number of points after 20 throws. So it's kind of tie between the two if they both have same. Now, so we have to identify. So this is how we will identify. Okay. The company wants a program to output the total monthly sales for one of the selected websites. The programmer codes a function with the following function header. So what is a function header? The first line of the subroutine is called function header. Okay, this is a function which is monthly website sales. This month is the first parameter, which is integer. This site is the second parameter, which is a character, and this particular function returns an integer. So it is expecting two parameters, this month and this site, and then it is returning a number. The function returns the total number of bicycles sold for the given month and website. The function will use the following: this month as integer, this site as character, the code as X for website X and Y for website Y. Whereas this month is the number of the month. All right. So give the number of parameters of this function. There are two parameters. Obviously, I told you that there are two parameters, this month and this site. So some of the following functions, function calls may be invalid. Ab dekhein, what you need? You need this month as integer first and this site as character. So integer and site. This is correct. All right, this is correct. Why? Because it has got two variables. First integer and the second one is no. This is incorrect. Sorry. Why it is incorrect? Why it is incorrect? Because it has got quotations, double quotations in it. Here, three argument. This one is correct. All right. So it might be something as little as this, that instead of double quotation in character, we have used single quotation. Oh, sorry. Instead of single quotation, we have used double quotations. All right. And then here, the expected number of parameters which are being passed on are two. Over here, there are three. Okay. Okay, I'm not going to study the whole thing. I'm just telling over here this part which is related. The algorithm above currently has 5 stages. Okay, 1, 2, 3, 4, 5. One technique for program design is to further break it down where required. Any stage to a level of details from which the program code can be written Name this technique, top-down design or decomposition. All right, top-down design or decomposition. Modularization. Just go on with one. Two operators available in a programming language which are div and mod. They perform integer arithmetic as follows. Xdiv. So basically, let's say I have got 16 and I'm dividing it with 3. So 3 5s are 15. Okay, so 1 is left. All right, so if I like to put this way, this will be 5.999. Oh, sorry, 5.33. If I just like to have this integer quotient known, in that case I will be using div. If I would like to know this remainder, integer remainder, I will be using mod. So 16 div 3 is actually 5 and 16 mod 3 is actually 1. All right. So x div y computes the number of times y is divided into x, this one, and x mod y computes the remainder when x is divided by y. Calculate the value of the variables shown for the following code arguments. 37 mod, this is remainder, so this is 7. So 10 3 times goes to 30 and then 7 is the remainder. Now quantity is 208, box size is 100. Quantity means 208 div 100. So this is basically 2. All right, so 100 goes 2 times in it. And quantity mod box size. Now box size is 100. So mod means 8. 8 plus 1, 9. Bank customers withdraw money from their accounts at a cash dispenser machine using this bank card. The machine operates as follows. It can dispense the following notes: 50, 20, and 10. Now, when a customer withdraws money, they enter the amount to withdraw. This must be multiples of 10. The machine will always dispense the least possible number of notes. A program is designed for the machine to process a withdrawal. The following variables are used: amount, $50 bills, and $20 bills, and $10 bills, and temporary. So $50 would have number of $50 bills, 20 would have $20 bills, and 10 would have temporary. Is used to calculate the number of each note required. Amount to withdraw entered by the user. This is the amount. So let's see. So you basically fill this table yourself. Let's just solve the question, and if it is related to the pseudocode, as in the subroutine. So it is not related to the pseudocode as in subroutine, so I'm going to skip it. Now, a flooring company provides for each customer an estimated price of the new job. Each job is given a job ID. All right. Job ID. The job cost is calculated from the length, nearest meter, and width of the room. Okay. A to E. So job cost, job customer name, length of the room, width of the room, and job ID. Okay. Then, okay, the process of calculating the price is as follows. So D will be send estimate to customer, job cost, the process of calculating the price, job cost, job ID, and what is E then? Let's see. The process of calculating prices as follows. The floor area is this. The structure shows here. What could be E? Produce flooring job cost. Estimated price job cost for a new job. Job cost. The process of calculating the price as follows. The floor area is calculated with 18% added to allow for the wasted job cost calculated. Floor area. It might be floor area which you have to tell. Okay. So this type of customer name. Yes, customer name can also be the part. Yes, it can be the part. So when we are sending it, we are sending it to a customer with the job ID, the name of the customer, and job cost. Yes, that could be the part of it. The procedure below is one of the modules shown on the structure chart. The parameters can be passed by value or by reference. Complete the procedure header showing for each parameter. Calculate job cost. Now you can see that this job cost is being calculated, but it is not being returned. Why it is not being returned? Because this is a procedure. Procedure does not return a value. So how come the caller will be able to know the job cost? Although the job cost is being returned from the calculate job cost. So it means that this is being shared. Job cost is being shared. So length and width is coming in. Job cost is also coming in, but length and width is by value, job cost is by reference. Okay, so length, width, and job cost. Job cost is being calculated since it is by ref. These two are by val. Okay, so length is by val, width is by val, but job cost is by reference. Since this length and width is being used, job code is being updated, and since this is a procedure, you do not return the job cost. All you have to do is to make it by ref. So see, the concept based questions are having more marks. No attempt has been made to validate the data entered by the user. Describe two different types of validations. We are not going to discuss this over here. A program is to be written. This is 2015. A program is to be written to calculate the discount given on purchases. A purchase may qualify for discount depending on the amount spent, the purchase price, purchase, the discount rate, and the amount paid is calculated as shown in the following pseudocode algorithm. All right. What is the question? The algorithm is to be documented with the program flowchart. Complete the flowchart. So this is sort of irrelevant. We are going to skip it. Now, Okay, this is a relevant question. A firm employs 5 staff who take part in training program. Each number of staff must complete a set of 12 tasks which can be taken in any order. When the number of staff successfully completes a task, this is recorded. A program is to be produced to record the completion of tasks for the 5 members of the staff. The test To test the code, the programmer makes the program generate test data. The program generates pair of random numbers. Now, what is random? Random is a function that gives any number in the given range. It's like a dice, which is when thrown, it can give you either 1, 2, 3, or sorry, it can give you 1, 2, 3, 4, 5, or 6. Okay. Now, a program is to be produced to record the completion task for the 5 members of staff. To test the code, the programmer makes the program generate test data. The program generates pairs of random number. The first in the range is 1 to 5. 1 to 5 means 1, 2, 3, 4, 5. These are staff members and these are tasks. Now, each pair of numbers simulates the completion of the task by one member of staff. Explain why the generation of 65 into 12 as in pairs of random number will not simulate the task. See, random numbers, random function, when generates a number, it can always generate same number several times. Why? Because random number function, when generates a number, it can always generate same number several times. That is why it is not necessary that if there are 60 possibilities, our random number will only generate only those 60 things which were never produced again. And if you realize, if you are having this dice in your hand and if you are throwing it, there are chances that the same number may reappear. You might have 3 one time, but 4 times, 5 like 3 times, 2 times. So that is always possible. So random number is not going to generate a number which is random. Random means that the number which is unexpected out of the given range. It does not mean that the number will always be the different number from the last time. Alright, so since random function does not generate the distinct random number always, there are chances that we will not be able to complete the whole thing in 60 turns. Alright, now the table shows that 2 members of the staff have each successfully completed one task. The program must use a suitable data structure to store. So you can see that this is 2-dimensional array. Okay. And this is of Boolean data type. Why Boolean data type? I can see all those empty are showing that this task is not yet completed by this staff member, but where it is ticked, it means that staff number 3 has completed it, the task 4. So it means this might be Boolean. All right. Since there are just 2 possibilities, either done or undone. Sorry, not done. The program will output the staff number and task number with the help of random numbers, and then it will tick it. But if it will put a tick over there, it means that that task has not already been completed. If the random number is generating a task which has already been completed, it means if it is a tick over there already, then we would have to regenerate it. Okay. So they have written the whole thing. Now, one thing that I want to tell you, which is quite important, look at this code from line 1 till line 24. From line 1 till line 24, this is the main program, which is not under any subroutine. So all the variables from here until here are treated as global. Whereas in this subroutine, you can see the word procedure. So these two are local. This is the nature of your past paper questions. I've got nothing to do with it. This is nothing which is a standard. This is how your syllabus works. The past papers work. So the program which is controlling all of the subroutine So this program is making use of this, yes, over here. This particular array, task grid, it has got two dimensions, staff number and task number. And you can see that the type of the array is true. That is why, sorry, Boolean. That is why they are assigning it either false or true. So if we have not decided, they would have already told you. Khatam ho gayi baat. Now first let's say या टास्क ग्रिड का जो एरे है ये बनाते हैं. So declare task grid as array which has got 1 to 5 staffs and 1 to 12 columns, which are the task per staff, and of what data type? Of Boolean. Okay. Now let's see. Give the line number for the declaration of a Boolean global variable. Boolean global variable is this. Line number 4. New staff task Boolean. Line number 4. Declaration of local variables. So these are two local variables, 27 and 28. So just give them 27, which is the first line. The incrementing of variable used as counter, but not to control a count control loop. Count control loop kaun sa hota hai, which is for next. So we don't have any for next, but we do have something like this. Completed is equal to completed plus 1, and this completed is being used in a precondition loop to find if the total has reached 60. So this is a basically incrementing. Why incrementing? Because incrementing is always plus 1. So completed is equal to completed plus 1 is meaning that the previous value is being incremented by 1. All right. Hi sir, hi. Big fan. Assalamu alaikum. Walaikum salam. I like your name, tomato potato. Wow. All right. So this is incrementing variable completed, which is being incremented at line 20. So the incrementing of variable, which is line 20. Okay. A statement which uses built-in function. Built-in functions are those which are not made by us, rather they are being provided by the pseudocode or the language themselves. So what are those? These are two functions which are these, random and random. So this is line number 11. This is the only place in the whole subroutine, all right, where there's a function being called and the function is the same, which is random. So this is random number generating number. Function. So this is line 11. State the number of parameters initialized task grid produced. I think it is 0. There were no. Initialized task grid does not have any parameter here. No parameters. All right, no parameters. Copy the condition which is used to control a precondition loop. Now we have got two whiles. Precondition are two whiles. So we would have to make a copy of this. While completed is not equal to 60, or maybe we have got another one. While staff task is equal to false. So these are two. You may copy anyone, and I would suggest that always copy the first one. Okay. If they ask for both, in that case you can do that. So explain the purpose of line 13 to 18. So let's see what is line 13 to 18. So let's make it stand out first. 13 to 18. Okay, if task grade staff name is equal to false. So this is checking if the location is false. It is making the location true, which is being used has completed this particular task. And then a global, sorry, okay. Now, please कोई बताएगा कि you can see me easily and you are hearing me out as well. Okay, thank you, sir. All right. Okay, let's move on. Now, Now there is one more thing, as the new syllabus states, that you might have a flow chart, and out of that flow chart you would have to write the code. This is possible. So other than those basic 4 or 5 flowchart shapes, there is a new shape which is this margined process box. This process box will be used whenever you are making a call to a subroutine. All right. So if you see over here, in this particular line of code, a function is being calculated and being passed a parameter. Whatever that function will be sending back will be assigned to new points. So this is depicted as like this over here. Rest will remain the same. Okay, so mind it whenever you see such thing. And one irony, although functions are not being called with the word call, over here in this particular case, for this type of pseudocode depiction in the flowcharts, we will be using this box. Even for functions, this way. All right. Now over here in this particular 2D array, we can see that all of the places are being initialized with false, and only 2 of those are turned to true. This is same as that question where we had 5 staff members and 12 tasks required to be completed by each staff member. Over here we have got 4 suits, club, diamonds, heart, and spades, and there are 13 cards in each of the suit. So this question will also be requiring you to have a random number generated, and this is same sort of question, different variants, and we would have same questions sort of. I'm actually skipping questions because I need myself to be focused over subroutines. Okay. All right. So this is one of the questions which relates. Now, structured programming involves breaking down of a problem into a number of modules. Give 2 reasons why this is done. Here we are required to tell about the advantages. A library of programs is written, the overall development time is reduced, things like that. Number of errors remains low, things like that. A team needs to write a program to implement an online shopping system. Customers will access the program via a website. Customers can search for items before adding them to virtual shopping basket. When they have finished shopping, they pay for the items. The program provides output for the dispatch of the time. Dispatch of the items. Some of the key features of the system are as follows. A customer can add many items to the shopping basket. Okay, as many as means. The payment may be either by credit card or the debit card. Okay. The shop may dispatch the item in 1 or more packages. Okay. The structure chart below shows the program modules only. Draw on the chart symbol that represent the key features. All right. So, customer can add many items to the shopping list. Search and add. Search and add. So, this will be something like this. So, this loop basically tells that these 2 things. You see, basically there is a sequence. It goes from left to right. But if you put this arrow This arrow might be in any direction, doesn't matter, but mostly we make it from right to left. So that tells that these two items are being repeated. So these two models are being called again and again and again. Payments may be either through debit card or credit card. So we have to have a diamond box over here. So this diamond box means the decision. It might be either credit card or payment card or account payment. Okay. Credit or debit card or by adding a customer account. Okay. All right. Now, the shop may dispatch the item in one or more packages. Print dispatch list, print address label. The shop may dispatch items in one or more packages. Print dispatch list, print address. So we don't have to put anything over here, I think. So that is how. So this loop tells that this particular subroutine is calling these two subroutines in basically inside a loop. All right. So inside a loop. This tells that there is a decision being made. If that decision is true, this is being called. If it is false, this is being called. And this means that it is being dispatched in sequence. So first this will go and then this will. Now, these A and B with the circle which are hollow in the middle are basically data couples. And with this one is basically with the circle which is filled with the color is said to be the flag. It means it is a Boolean variable which is being returned by this particular subroutine. So checkout is calling this subroutine with A and B, and C is being returned. A section of the chart in part B1 is shown below. It is to show parameters passed between the checkout and the card payment module. All right. Name the three data items corresponding to arrows. So you read the situation, complete situation, find out which are these two, but I can tell that this is a flag. Flag is basically a variable which is Boolean. All right. So when a function is returning a Boolean value, it is said to be a flag. Evaluate the following expression, my string and all. Okay, leave it. So the C and F are flags. A, B, D, and E are basically data couples. Okay. Now, this looks connected. A string handling function has been developed. The pseudocode for this function is shown below. Function SF just receives one parameter and returns a string. And these are X, new string, flag, M, and N. They all are what? Local variables. Okay. So now the flag is initialized with true and the new string is initialized with null value. M is equal to length of this string. So this is an inbuilt function that tells that whatever the value of the new string, which is this string which is being received, it will be counted for its characters, number of characters, and those characters will then be assigned to the number of those characters will be assigned to M. So then it goes on for every single character from 1 to M. If the flag is true, then it is actually reading one character in turn, converting it to uppercase and assigning it to X and then making it false. If the flag is true, since the flag is true, it will happen. So every single character will be picked up from the start, run the length through the end, one character at a time will be turned to the uppercase and will be assigned to X, and false X, flag will be turned to false. And then in next turn, if the flag is still false, then it means that the character will be basically turned to the lowercase. It seems like they are actually turning every first character of the word to the uppercase. It looks like that. Yes, it is basically like that. So they are reading every character in the whole sentence and making the first character of every word capital. That is what they are doing. All right. They might be asking test data must be designed for SF. State what happens when the function is called with the empty string. Function will be called with the empty string. In that case, this loop will not work and the new string will be returned as it was initialized. So null string, null new string will be returned. The function should be thoroughly tested. Give 3 examples of non-empty strings that may be used. In each case, explain why the testing has been chosen. All right, so the name of the function is, so my string, this is the call from the calling subroutine, is equal to SF. I might be wanting to check what happens if the word that is being sent is a single word. So I want to check it. So I'll write it. I might be wanting to check what if only a single character is being sent. In that case, what will happen? They want you to put non-empty string and you want to check what happens. So I might like to see what happens if I send the whole sentence. So these are these sorry, these are 3 test data items which are being sent and being checked for. And what are those? In first, I have sent a word with the first letter capital. Then in the second one, I have sent a single character which is small. Let's see what happens to it. And then in third, I'm sending the whole sentence with the first word with the capital character and the rest 2 of the words with the small capital. So I would like to check that what happens if the word is a single word and it has the first character already capital. What happens if the word is not a word, it's just a single small character, what system returns or the function returns. And in third case, I'll be sending a sentence which is a proper sentence. And what happens when it is being returned. And I'm expecting that when it is being returned, Zafar would have Z bada, A would have A capital, and Khan would have K capital. So this seems like a question which is for the procedure, but it is mainly the string manipulation function itself. A programmer wants to design a procedure to calculate the customer ID number from the customer's surname. The procedure will input the surname, isolate each character in the surname and find the corresponding ASCII code, calculate the total of those ASCII codes, and this total is the customer ID. So length is equal to length of surname, and then customer ID is equal to 0, I is equal to 1 to surname. So next character is mid of surname, comma I, comma 1. So one character is picked up, and then next code number is equal to ASCII of the next character, and then customer ID is equal to customer ID plus next code number. So this is a very simple one. The programmer decides that it would be better to write the program instead of a procedure as a function. The user will now input the surname in the main program, write the main program. अब देखें, whatever that is being done over here will be taken out. All right, and this procedure will become a function. All right, function, and it is now expecting surname, and it is returning what, which is being output, a string. All right, so this thing will also go out in the main program. Okay, so you would have to rewrite the program. The additional statements require the function body to be completed to complete the change from the procedure to function. We have done it. The statement in the main program which calls the function for surname will keys. So the name of the function is this, calculate customer ID, assign it to this ID. So this will become, this ID is equal to calculate customer ID with will keys. That is how we will send it. This function will be called, this value will be transferred, that value will be received by the function. It will return this string, this string will be returned to this side. That's it. The new function calculate user ID is an example of user-defined functions. Yes, state two differences between built-in functions and user-defined functions. Built-in functions are from the language which we are using, predefined, and the user-defined functions. Yes, you may, beta. And user-defined function is the one that we write ourselves. Built-in functions are predefined, pre-seen, pre-tested, widely tested, error-free, but those which are defined by us might have errors. State two things that built-in and user-defined functions have in common. One, they may or may not receive the value, and they both returns a value. A company employs a programmer. Okay. This is irrelevant. This is relevant this way. This is a structure chart question. One thing I want to tell you that, let's say if there is a subroutine which is calling another subroutine and another subroutine, and this subroutine might be passing two parameters and might be having one back. So those parameters which are passed by reference would have two arrows pointing in the both directions, starting from the circle. It means that the value that is being shared is by reference. So if you see anything like this, this is by ref. Okay, if you see anything like this, this is by ref. Okay, so this is by ref. All right, so this is a function or procedure or subroutine call. Let's see if there are other questions which relate. No, that's it. So that's about it. I have discussed so many questions, but you can see these questions are very rarely directly about procedures and functions. Mostly they are about the program for which they are written. They might be written for string manipulation, and that string manipulation is part of the subroutines and all. So rarely there will be questions which are directly related to it. Yes, the structure chart is one of the area. The structure chart is one of the area which is heavily consulted in past papers. So be very much confident about that structure chart, do watch separate lecture which I have already recorded and uploaded for structure charts and be good with it. So let's see. Now, stop testing debugging. Debugging is basically removing errors. Sir, we have to solve flowchart question as well, or we can leave it. No, 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 no. I'm skipping those because those are not relevant with the subroutines thing, but they are highly relevant. And your syllabus says that you would have flowcharts given, and out of those flowcharts, you would have to write the program. I just skipped those because our topic at the hand was subroutines, not the flowcharts and all. You cannot. This is a part of the syllabus, and you can see that while we were surfing through this file, we saw this flowchart question like 4 or 5 times. So the probability high. Now debugging. Debugging means removing errors. So white box testing, we discussed about it at white box testing the user, when the user, the developer actually when they are making programs, once they are done with it, they check it line by line for all of the possible pathways. That is called white box testing. Black box testing is basically the integration testing, means when all the subroutines are put together, their interactions, their interactions, their parameter passing, and other things, how they work, and if they are working together as a single program without any errors. So that such type of testing is called black box, because in that we are not concerned about the logic of the individual subroutine. Rather, we are concerned about how those subroutines, when they are put together working as a single program, if they are working all right or not. When that is being done, the black box testing, when it is being done, better don't raise hand, just ask the question. When that is being done by the developers themselves or the software house, it is said to be alpha testing. And when that is being done, for alpha testing, it is a necessary requirement that all the test data and their expected results are predefined. So alpha testing is always, it is integration testing. Integration testing means how different subroutines are being interacting with each other, if they are interacting okay. So because there is possibility that when individually those subroutines were defined, designed, and developed, they were working fine. But when they are interconnected, when they are being used as a part of the program, as a unit of the program, they might have issues. So as a whole, they are part of a program and they should work properly as per the expected plan. So such type of testing is called alpha testing. And when that same testing is being done at the user side or those customer side which have ordered for it, and without predefined data, but rather with the data which is basically the customer's actual data, is called beta testing. It is not beta, it is not beta, it is beta. Stub testing is when these subroutines are made by the programmer, their length and complexity differs. So if it is more complex than others and bigger than others, definitely it will take more time. So while a bigger subroutine is being done, other smaller subroutine might have already been completed and submitted back to the project manager. So what project manager would do, they will make fake subroutines to fill in the space of those which will be developed later afterwards and will be submitted back. So for those fake subroutines, the testing cannot be stopped. So what the project leader does, they make fake subroutines and they check actual subroutines which are already made and submitted back. And as soon as a subroutine is completed, its stub is replaced with the actual subroutine. Yes, the stub is called those subroutines which are fake and they are just filling in the space until the actual subroutine is completed and submitted back, so that other subroutines which are periodically completed are being completed and being submitted can be checked is called stub testing. So that's about it. So this completes our subroutines topic, and in the next class we will start with another new topic. So you are required to understand it thoroughly. Every single program that you would write this moment onward should be either a procedure or function. In Visual Basic, we call procedure a subroutine, a sub, and a function is called function. When you practice it in Visual Basic, this would be a different case. And in Pascal, we use the word def. So different languages might take different words, but the whole concept remains the same. So those subroutines which return a value are called functions, and those which do not are called procedures. But they both can accept parameters. Can accept means that sometimes there are no parameters. So that's about it. If there are any issues afterwards, please do ask me. Whatever the channel that you have with me, using that channel. And that's about it. I see you Sunday morning. Take care.